let's now talk about mixed strategies. What we've been looking for so far is a pure strategies Nash equilibrium, where your strategy is actually like a certain choice, like in this game, either rock or paper or scissors. Now, in games like this, if you sort of go through it, you can see that there is no Nash equilibrium strategy. Bart has this idea that he's going to play rock, and that's predictable. Lisa's played with him in the past. She knows that, so she knows he's going to throw rock. It doesn't actually matter that it's rock. It could be any one of the three. But if his strategy is predictable, if she knows exactly what he's going to do, she can exploit that. She can win. Okay? And so the idea here with mixed strategies is maybe what you want to do is you want to not be predictable. In a lot of zero-sum games, there is no pure strategy Nash equilibrium, but there is a mixed strategy Nash equilibrium. What a mixed strategy is rather than choosing a particular choice, it's choosing a probability for each choice, right? So you might have a probability for rock, a probability for scissors, etc. Right? And the goal is choosing those probabilities to prevent your opponent from exploiting. Okay, so let's consider a specific example. My favorite example to use, Roger Federer. For those of you who watch tennis, you'll know that Roger Federer has an amazing forehand. And he has a pretty good backhand too, but his strongest shot is definitely his forehand. There you go. You see, he just absolutely unleashes it. Okay? And you can see some of the times what he actually does is he actually kind of runs over to his backhand side. You know, he's actually running over a little bit to the left of the screen so that he can turn what would be a backhand into a forehand. You can actually think of this as somewhat of a risk. If he runs around the backhand and turns it into a forehand, okay, he basically runs all the way to the left side of the court, then he's actually leaving the right side of the court empty. Now, that's sort of a calculated risk. Sometimes he does that. So you can think about it this way. Federer, basically, every time the ball's about to be hit to him, has two options. He could run left, that's run towards his backhand side, and if Nadal would hit it towards his backhand side, then Federer could turn that into a forehand. And, you know, he has a ridiculously good forehand, so that gives him a pretty good chance of winning the point. So let's say he runs left and Nadal hits to Federer's backhand side. Then we'll say that the probability that Federer wins the point is 80%, and the probability that Nadal wins the point is 20%. Okay? The other option that Federer has is he could stay central. Okay? If he stays central, then he can presumably make it to either a forehand or a backhand. He's not going to be leaving part of the court empty. But if he stays central and then Nadal hits to Federer's backhand side, then Federer doesn't have time to run around it and turn it into a forehand. So he has to use his weaker shot, his backhand shot. And that doesn't give him as much of an opportunity to win the point. Now let's think about it from the perspective of Federer. But we're actually going to, we're thinking about Federer's perspective when we're trying to figure out what probability he should choose for one of his options. Let's say the probability of running left. Right? Okay, so let's take a step back. What does it mean to have a probability? Imagine that Federer has like a random number generator or some sort of, something like rolling a die in his head. And every time Nadal's about to hit it, he rolls this die. Or let's say he's rolling a die that has 100 sides, numbered 1 to 100. If the probability is, let's say, 10%, if the die comes up between 1 and 10, we would say that then Federer would run to his left. Okay. And with any other roll of the die, Federer would stay central. Okay, so that's kind of what's happening in Federer's head. Now what he wants to do is he wants to select the probability that prevents Nadal from exploiting him. And now to actually try and answer this question, what we're going to do is we're going to write down the expected sort of probability that Nadal wins the point for each of his actions. So if he hits to Federer's backhand side, what is the probability that Nadal wins the point given the probability that Federer chooses for running left? And likewise, we're going to get the expected payoff to Nadal if he hits to Federer's forehand side. If Nadal hits to Federer's backhand side and Federer runs left, then Nadal's payout or probability of winning the point is 20. Okay, so he gets a payout of 20 with a probability P, where P is the probability that Federer runs to his left. And then he gets a payout of 80 with probability 1 minus P. So it's the remaining probability, the probability that Federer stays central. This is the expected payout that Nadal gets if he hits to Federer's backhand side. We can similarly calculate the expected payout that Nadal gets if he hits to Federer's forehand side. So it's going to be the probability that Federer runs left, which is P, times Nadal's payout in that case, which if Nadal is hitting to Federer's forehand side, his payout is 90, plus the remaining probability, that's a probability that Federer stays central, which is equal to 1 minus P, times Nadal's payout in that case. So now we've written down Nadal's expected payouts from his two strategies as a function of Federer's chosen probability of running to the left as opposed to staying central. So these two lines on this graph show Nadal's probability of winning the point under a given strategy as a function of Federer's probability of running to his left, which is shown on the horizontal axis here. Okay, so this orange line is the payoff that Nadal gets in expectation if he hits to Federer's backhand. And this blue line indicates the expected payout that Nadal gets if he hits to Federer's forehand side. See that if there's a relatively low probability that Federer runs left to try and turn that backhand into a forehand, then Nadal gets a very high payoff of hitting to Federer's backhand side. And we can see that Nadal's payoff declines as the probability that Federer runs left to turn that backhand into a forehand increases. Now this blue line here shows the payoff that Nadal gets if he hits to Federer's forehand side. Now, of course, the higher the probability that Federer runs to the left, Nadal's probability of winning the point increases. Okay. Now, just as Lisa tried to take advantage of Bart's predictability, Nadal is going to try and take advantage of Federer's strategy. Right? So for any probability that's less than 0.3, we can see that Nadal gets a higher payoff of hitting to Federer's backhand side than he would if he hit to Federer's forehand side. For any higher probability that Federer runs to his left, we can see that Nadal's payout is higher if he hits to Federer's forehand side than it would be if he were to hit to Federer's backhand side. Right? So we can assume that Nadal is going to take whichever strategy is better for Nadal. So Nadal's payoff is sort of the upper envelope of these two lines. It's sort of the upper V that's made by these two lines. Now, if we think about that, Federer's strategy is to maximize Federer's probability of winning the point, which is the same thing of minimizing Nadal's probability of winning the point. Okay? So where is Nadal's probability of winning the point minimized if he's going to take the better of his two strategies? Well, you can see here, it's where these two lines cross, which is the place where Nadal's expected payoffs of each of Nadal's two strategies, hitting to the forehand or hitting to the backhand, are identical. Okay? And that actually shows us how we're going to solve this problem mathematically. We've already written down Nadal's expected probability of winning the point when he hits to the forehand and hits to the backhand side. So we have sort of two different expected payouts for Nadal under his two strategies. And we're just going to set them equal to each other and find the probability P that equalizes Nadal's payout under those two strategies that Nadal has. So what we're going to do is we're going to set Nadal's expected payoffs from the two strategies equal to each other. And then we're going to solve for P. So if I sort of simplify this a little bit, simplifying the left-hand side, we have 20P plus 80 minus 80p is equal to 90p plus 50 minus 50p. Let's simplify this a little bit further. We have 80 minus 60p on the left-hand side, and that's equal to 40p plus 50 on the right-hand side. And then if we were to subtract 50 from each side and add 60 times p to both sides, we would get that 30 is equal to 100p. And then if we divide both sides by 100, we get that 30 over 100 is equal to p. And the probability is 0.3. 0.3 or 30%. So Federer's optimal strategy to prevent Nadal from exploiting is to set the probability that Federer runs to the left equal to 0.3. And that gives Federer's optimal mixed strategy. Okay? Now, likewise, if Nadal is predictable, Federer would want to exploit Nadal's strategy. Okay? So Nadal is also going to want to randomize. Nadal is going to want to choose a probability to equalize Federer's payoffs from his two strategies, which are running left and staying central. So let's start by writing down Federer's payoffs if he runs left as a function of the probability Q that Nadal hits to Federer's backhand. Okay, so Federer's expected payoff is 80Q plus the remaining probability of 1 minus Q, that's the probability that Nadal hits to Federer's forehand, times Federer's payoff in that case, which is 10. Okay? So this, what I've written so far, is Federer's expected payoff if he runs left. Now we're going to want to do the same thing, find Federer's expected payoff, but under his other strategy of staying central. If he stays central and Nadal hits to Federer's backhand, then Federer's payoff is 20. Of course, Nadal hits to Federer's backhand with probability Q. Let's add to that Federer's payoff if Nadal chooses his other strategy, hit to Federer's forehand, in which case Federer's payoff is 50, times the probability that Nadal chooses that strategy. And to figure out Nadal's optimal probability Q to prevent Federer from exploiting Nadal, what we're going to do is we're going to find the probability Q that equalizes Federer's expected payoffs under Federer's two strategies. So for Nadal, his optimal strategy of the probability Q that he hits to Federer's backhand is that that probability should be 0.4, or 40%. So the mixed strategy equilibrium in this case is that Nadal hits to Federer's backhand with probability 0.4, or 40%, and Federer runs left with probability 0.3 or 30%.